Okay, good day class. Alright, so this video going to continue a little bit more of topics 5.1.3, okay, which is differentiation and integration of a power series. So means that how we are going to apply this Maclaurin series in differentiation and also integration. Okay, so means that we apply standard Maclaurin series plus differentiation and integration. Alright, so what we are going to do at this part. So number one, we are going to use Maclaurin's theorem or standard Maclaurin series. So we may express many functions in the form of convergent power series, or like what we have done before. Then number two, then by differentiating and integrating a convergent power series of a function, we can find the Maclaurin series for another function. See, means that we already have an expansion of a function. Then we differentiate the function, we differentiate the expansion, or we integrate the expansion. Then we will get the expansion for another function. This is what we are going to do. All right, number three, the interval of convergence of a series obtained by differentiation will be same as for the original power series. So this one no problem. And number four, the interval of convergence of a series obtained by integrating may be same of the original series or include more values than the original power series. Okay? Alright, so honestly, I cannot find many examples in this part. Not in other other reference book also. And so far this part never come out in STPM. So what we have is only the three examples in your textbook. Alright, so I'm going to discuss these three examples in your textbook. Alright, which is example 14, 15, 16 in page 165. Okay, so now we refer to the textbook. Okay, first is this one. So we enlarge a bit, so maybe you can see better. You can refer to your textbook also if you want. Alright, so this is the first one. Okay, you see the sound like this. Write the Maclaurin series for 1 over 1 minus x. Alright, hence find the series expansion for 1 over 1 minus x squared. Okay, use this Maclaurin series, standard Maclaurin series, to find the expansion for this one. Alright, so we know that if you have one original like this and you want to get this one, when you move up, is power -1. Alright, and only differentiate will make it become power square, right? Because this one move up is power -1. So only differentiation index -1. So -1 minus 1, -2. And when you shift back, you get this. Alright, so from here to get this, we know that we have to use differentiation. Alright, okay, so first step, very simple, really simple. Okay, first step, use this standard Maclaurin series. Alright, this is the standard Maclaurin series for 1 over 1 minus x. Then we differentiate both sides. So differentiate 1 over 1 minus x squared. 1 over 1 minus x, you have 1 over 1 minus x and square. Correct, right? 1 over 1 minus x is 1 minus x power -1, right? Okay, then when you differentiate it, so index in front, index minus copy, then index -1. Don't forget multiply, differentiate inside, right? So differentiate inside here is -1. Right? So -1 become positive. Correct? So differentiate left hand side, you get this. Then you just differentiate each term here. So differentiate 1, you get 0. Actually differentiate 1, you get 0. Differentiate x, you get 1. Or 1x 1. Differentiate x squared, you get 2x. Differentiate x cubed, you have 3x squared. Until the general term, index in front, index -1, plus the dot. Okay? So this is the expansion for 1 over 1 minus x squared by using differentiation. It's just that simple, okay? And the interval same as the original one. Alright? For differentiation, they say same, right? Remember? Okay. So this is involve differentiation. Okay, now we see another one, which involve integration. Let me see. Okay. so this is the question. Okay, using the result that integrate 1 over 1 plus x squared. You please change it. Oh, I think there is some printing error. Okay, so using the result that when we integrate 1 over 1 plus x squared from 0 to x dx, we get arctangent x. Alright, so don't worry, you will actually learn this one in chapter 3. Okay, so we are going to just use the result of this integration. Find the series expansion for arctangent x. Okay, so actually this part no need lah. Okay, it's something extra. So just okay, we don't have to see this. Alright, so what standard standard Maclaurin series that we're going to use? We are going to use this standard Maclaurin series. Oh, this is different than just now lah. Just now differentiation now integration So means I want to get 1 over 1 plus x squared. Alright, so to get 1 over 1 plus x squared, I start with this standard Maclaurin series, 1 over 1 plus x. So this is the standard Maclaurin series for 1 over 1 minus x, 1 over 1 minus x, okay? Then 1 over 1 plus x squared means 1 over 1 plus, cannot see, okay. Or maybe I write here, okay. 1 over 1 plus x squared, I can write as 1 over 1 minus negative x squared. Okay. Remember, this square belongs to x. Cannot write outside. So means that now you are going to sub all the x in this series become negative x squared. Okay, like what we have done before this, the composite function one. Alright. So you see, they sub all the x become negative x squared. Then you simplify it. Okay, so this is, we find the expansion for this function first. Alright, then we integrate both sides. We integrate both sides of this function from 0 to x, where x lies inside the interval of convergency. Therefore, from here, arctangent is equals to this, right? So arctangent is equals to integrate 1 over 1 plus x squared dx from 0 to x. Alright? And 1 over 1 plus x squared, we already find it. The expansion is like this. Okay? And using the integration, can you see? Can I see? Okay, sorry. Okay, just now, okay, repeat again. So just now from here, from the question, we know that arctangent x is integrate 1 over 1 plus x squared dx from 0 to x. Alright? And 1 over 1 plus x squared, we already find the expansion. Just sub in. Okay, from 0 to x. Then just integrate. You learn integrate in form 5 already, right? So integrate x, you get integrate 1, you get x. Integrate x squared, you have x cubed over 3. Integrate x power 4, index plus 1 x power 5 over the new index. So integrate x power 6, index plus 1, x power 7 over new index. Okay, plus dot 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 from 0 to x. So this is definite integration. So definite integration means sub the upper limit into it, sub x into it, so you just copy only, sub 0 into it, minus what? Minus sub 0 into it, sub 0 into it, all becomes 0. Okay, so left this thing only. Okay, so this is an example how we use integration to find the expansion for a new series, of a new function. Use integration. Use the concept of integration to find the expansion for another function. Okay? So this is related integration. And here stated that the interval of convergence of the series obtained by the integration may include more values than the original series. Here, the interval of convergency of the series for this one is -1 and 1. Same like this, but have something extra, more than it, right? Include -1 and 1. Before this, not include. Alright, this one include. Because we know that arctangent equal to 1 or -1. Alright, in the function, yeah. Okay, Okay, next. The last example is this one. Yeah. Okay. Use the Maclaurin series for 1 over 1 minus x. Express ln 1 plus x as a series up to the term in x power 4. We are using integration concept. Of course, you can find this by using the standard Maclaurin series. Right? This is actually a standard Maclaurin series. But now we are going to see how we can use integration, or how we can use integration to find the expansion for ln 1 plus x, or other than using the Maclaurin's theorem. All right. Okay, so you see original function is 1 over 1 minus x, and we want to get ln. So we know that only integrate 1 over x, you get ln x. Remember, differentiate ln x, you get 1 over x, right? Differentiate ln x, you get 1 over x. So integrate 1 over x, you get ln x. Alright, so if you have 1 over 1 minus x and you want to get it in ln, so we know that we have to integrate them. Okay, so we start with this standard Maclaurin series, 1 over 1 minus x. Then we find the expansion for 1 over 1 plus x. Alright, so 1 over 1 plus x is equal to 1 over 1 minus negative x. Alright, so you just sub all your x in this series, become negative x. Alright, then elaborate it, simplify, and you get this expansion for 1 over 1 plus x. Okay, so now we integrate both sides. Oh, it's slightly different compared to the previous example. This one given. Oh, this one given. Okay, what else for this one? After we get this expansion, we integrate both sides. Integrate left hand side with respect to x, integrate right hand side with respect to x. Alright, this example slightly same as the example 14, the differentiation, right? We get the expansion, then we just now example 14, we differentiate both sides. Now we integrate both sides. Integrate this one, integrate this one. Okay, integrate 1 over 1 plus x is ln 1 plus x. Then integrate this one by 1. Integrate 1 is x, like just now, integrate 1 by 1. Okay, by right, you must have this one, this step. From 0 to x, sub x into everything, then you get the same thing. Then minus sub 0, because all with x, right? So when you sub 0 means all becomes 0. Okay, suppose you have to show this step. So for this example, they skip, okay, they skip the step and straight go to the answer. Alright, so this is the part 5.1.3. Okay, how we use differentiation and integration to get the expansion of a function by using some standard Maclaurin series. Alright, okay, so this video is just for this. Alright, okay, thank you.